Different apparatuses are used in chemistry laboratory for carrying out various experiments. Here you can see different solutions are kept in apparatuses which have similar shape but their capacities are different. Can you identify these apparatuses? They are beakers of different capacities like 100 milliliter, 250 milliliter, 500 milliliter, etc. We can call them a group of beakers. Let us find if any such groups can be identified in organic compounds also. Certainly yes, and it is known as homologous series. Many such series are found in organic compounds. Homologous series is a group of organic compounds having same functional group. Each member of the particular homologous series is called homologue. All the members of same homologous series can be represented by a general formula. The successive members of the same homologous series differ by Ch2 unit or 14U. All the members of a homologous series show regular trends in the physical properties and they have same chemical properties. It seems difficult. Let's decode it with the help of homologous series of alkanes, the simplest hydrocarbons. The homologous series of alkanes comprises of methane, ethane, propane, butane, pentane, hexane, heptane, octane, and so on. All of them are called homologue. Remember, methane is the first homologue of homologous series of alkanes. Did you notice? These compounds have different number of carbon atoms, but all the carbon atoms are bonded to each other by single covalent bond. This means they have the same functional group. All the members of homologous series of alkanes can be represented by a general formula CnH2n plus 2. Here, N is the number of carbon atoms and can have values 1, 2, 3 and so on. Notice that the successive members of the homologous series differ by Ch2 unit. The atomic mass of carbon atom is 12U and that of hydrogen atom is 1U. So, we can say that the successive members of a homologous series differ by 14U. All the members of homologous series of alkanes show similar chemical properties. It means they will produce compounds having same functional group when they react with the same reactant. For example, all the members of homologous series of alkanes react with chlorine in presence of sunlight to produce corresponding alkyl halide. But are the physical properties of all the members of homologous series also same? No, they're not same. In fact, a regular variation is observed in the physical properties such as melting point, boiling point, density, etc. This is all about homologous series of alkanes. It's time to take another example of homologous series of alkenes. Ethene is the first member of this series. Propene, butane, pentane, hexene, heptene, octene are some other members of this series. Why methane is not the first member of this series? Let's find. Notice, all the alkanes contain at least one carbon-carbon double bond. Since the presence of two carbon atoms is essential for the formation of a double bond, methane, a single carbon compound, does not exist. Hence, ethene is the first homologue of homologous series of alkenes. All the alkenes can be represented by a general formula CnH2n. Here, N represents the number of carbon atoms and its values can be 1, 2, 3 and so on. Notice that each successive member of the series differ by Ch2 unit or 14U. All the alkenes show similar chemical properties. For example, all of them react with hydrogen in the presence of catalyst like nickel or platinum and form alkanes. Talking about the physical properties of homologous series, you will notice that they show gradation in physical properties. That was all about homologous series of alkenes. Members of homologous series of alkynes are characterized by the presence of at least one carbon-carbon triple bond in their molecules. The first member or homologue of this series is ethyne, as methine does not exist. Other members of this series are propyne, butyne, pentyne, hexyne, heptyne, octyne, and so on. The general formula of alkynes is CnH2n-2. The successive members of alkyne series differ by CH2 group of 14U. They show gradation in physical properties. For example, alkynes having 2 to 4 carbon atoms are gases, those having 5 to 12 carbon atoms are liquids, while those having more than 12 carbon atoms are solids. Looking at the chemical properties, all the homologue of alkyne series give addition reaction with hydrogen in the presence of catalysts like nickel, palladium, or platinum. Apart from the homologous series of alkanes, alkenes, and alkynes, homologous series of alcohols, aldehydes, ketones, carboxylic acids, etc. are also known to exist.